to open the function of present line, but it's not good for me to directly have the function, so I'll just continue. In this chapter, if you have the selected distribution, for example, not percent, half is percent, but about the service time, you don't want to use exponential again. You can have the current chapter to know how to generate distribution rather than exponential. So this chapter actually, we have the way to implement, how to have the different distribution, not exponential only. So that says far from everyone, at least, not percent only. Sorry, not exponential only. Alright, so you can choose the others. If you just have a Bernoulli simply, sure, I expect you to have a more complicated one as well. So the current chapter actually we already have the approaches to generating random variables. And we have a continuous discrete and the empirical one. And finally put them together. We still get back to discuss generating arrival process. I already have percent, so we can have a batch percent. And in fact, if you have all the material here, actually you will have the willing to choose a bit more complicated model. So after now you have your selected model. It's possible to change your model further, right? Previously, I want to have an issue like this, but I want to have an even harder issue. Sure, you can try to move on to have a challenging issue further. So we want to have the distribution and generate the random variable. So how to do? The basic idea is at least we have uniform. And uniform is enough for us to have the generation. So how to have the generation? Actually, we already have a transformation. So we have a black box. And how to implement the black box, actually we already know. But right now, it seems we have a black box. Through the black box, then we can return the random variable. So this is the simplest image. All right, that's our uniform first, and then we have the transformation. And actually, if you have the black box, we will consider, can you have the exact black box? All right, so this one, exactness. Even you have the correct one, fast or slow to generate a random variable, so efficient. Actually, it should be efficiency here. And also, efficiency here, should you consume more storage space? If yes, then the efficiency is low. And also, how complex it is, we have a complexity. And also, if you have the model, can you apply to a maybe different situation? Suddenly we have the robustness. So we can check all of this, but it doesn't mean we can find one can fit all. Impossible. For example, we have a complex model, so can you have the good efficiency? No, right? So some of the factors, they have the conflict. So you just check which one you prefer. And later we check all these about exactness. Sure, if we have a z, how to have a z? It's easy. Generate uniform, and then minus this, then you can have the normal distribution. If we follow the equality, that's fine. And the efficiency, right now you cannot see it, but we expect fast. So it says we have the fast one, but maybe we have the others. All right. And complexity, if we have the simple one, then we have a low complexity. And actually, we can check the others. And in fact, we have a 4-factor list. I failed to check robustness, but actually in that part, we have the discussion about robustness. But I skipped that one.